The purpose of this video is to help you remember what to do when you are finding the volume of a cone. The formula that you should use when you're finding the volume of a cone is volume equals 1/3 times pi times the radius squared times the height. When you're finding the volume of a cone, what you are actually measuring is the number of cubes of a given size that can fit into a shape that is in the shape of a cone. The difference between finding the volume of a cone and the volume of a cylinder is that a cylinder will hold 3 times as many identical cubes as a cone with the same circle. Or in other words, a cylinder has a circle on the top and the bottom. A cone only has a circle on the bottom. So a cylinder will hold 3 times as many cubes as a cone with the same base. So if the circle on the bottom and top of the cylinder is the same as the circle on the bottom of the cone, and they have the same height, then 3 times as many cubes will fit into the cylinder as will fit into the cone. That's why the volume of a cone formula is 1/3 pi r squared h, because only 1/3 of the cubes will fit into a cone. When you're using the formula volume equals 1/3 pi times radius squared times h, and you're looking at a picture of a cone, the radius is the distance from the center of the circle on the base of the cone to the edge of the circle on the base of the cone. And the height of the cone is the perpendicular distance from the circle at the bottom to the point at the top. So that is the radius and the height. Those are the two measurements that you'll be using to find the volume of a cone. Example 1, find the volume of the cone. So we want to know how many identical cubes can we fit into a cone that has a radius of 3 centimeters and a height of 6 centimeters. So we'll take our formula, volume equals 1/3 pi times radius squared times h, and we'll have volume equals 1/3 times pi times 3 squared times 6. And so if you take your calculator and you type that in using your fraction button for 1/3, your pi button for pi, your exponent button for 3 to the second power, and you type it all in at once, the answer will come out in one step. Your calculator screen will read 18 pi. And we want to get our answer rounded to the nearest hundredths place. So when you hit the SD button on your calculator, your answer will come out to approximately 56.55 centimeters cubed. So what that means is a little bit more than 56 of those cubes that are 1 centimeter by 1 centimeter by 1 centimeter will fit into our cone. And so the volume of our cone is 56.55 centimeters cubed. Example 2, find the volume of a cone. In this problem, our radius is going to be 7, and our height is unknown at this point. But because the radius and the height and this 25 right here, which is referred to as the slant height, those three measurements make up a right triangle. In order for us to find the height, we're going to use the Pythagorean theorem. So we have c squared equals a squared plus b squared. Our longest side, or the side across from the right angle, is 25. That's our hypotenuse. So 25 squared equals 7 squared plus, I'm going to use h for my variable since we're finding the height. So that'll be 625 equals 49 plus h squared. And we subtract 49 from each side. and we'll have h squared equals 576. And then we take the square root of both sides so that we find h instead of h squared. And the square root of 576 is 24. So this first part of the problem was just so we could find out that the height of this cone is 24 centimeters. Now we're ready to use our formula. So we have volume equals 1/3 times pi times 7 squared times the height, which is 24. And so again, we can just type that into our calculator exactly the way it looks using the fraction button, the pi button, and the squared button. And when you type all of that in, you'll get 392 pi. And on our problems today, we want to get the answer rounded to the nearest hundredth. So when you hit the SD button, your volume will be approximately 1,231.50, and that will be centimeters cubed. So what this means is we can fit a little bit more than 1,231 1 centimeter by 1 centimeter by 1 centimeter cubes into this cone. Example 3, find the height of the cone. And when you look at this problem and you see that the height is missing, the first thing that might cross your mind is that you're going to use the Pythagorean theorem. But then when you look more closely at the right triangle, you can see that we know that one side is 4, one side is the height that we're looking for, and there's no measurement on the other side. So this is a problem where we can't use Pythagorean theorem to find the height. But we do know the volume on this problem. So we're going to use our volume formula. So to find our height, we're going to replace the V with our volume, 50.26548246. We're going to replace the R with our radius, which is 4. And then our variable is our H, the height that we're looking for. So now we need to take this equation and we need to solve that equation for H. So the first thing that I'm going to do to solve that equation is I'm going to divide both sides of the equation by pi. So the right side of the equal sign is divided by pi and the left side of the equal sign is divided by pi. And when I do that, 50.26548246 divided by pi is exactly 16. So now I have a 16 on this side and a 1/3, the pi's have divided out, 4 squared times h. And that's what I have for my problem at this point. Now I'm going to multiply both sides of my equation by 3. And what that will accomplish is that will remove the 1/3 from the right hand side of the equation. So 3 times 16 is 48. And 3 times 1/3, right when I'm multiplying by 3, I'm also dividing by 3 at the same time. So that'll just divide out, and I'll be left with 4 squared h. Now I'm going to square the 4, so I have 48 equals 16h. So 4 to the second power is 16. And finally, I'm going to divide both sides of my equation by 16. And 48 divided by 16 is 3. So I just found out that the height of my cone is 3 meters. Problem number 1. Find the volume of the cone. Problem number 2. Find the volume of the cone. Problem number 3. Find the height of the cone.